Hello, statisticians. Mr. Youngsaver here from Skew the Script. Today, we're going to analyze whether new policies from politicians actually help the middle class. To do so, we're going to compare distributions and use box plots. Let's skew it. Today's lesson is on box plots and comparing graphs. This is lesson 1.5 in our course sequence. In 2017, President Trump signed into law one of the largest tax reform bills we've seen in decades. Here's a quote from Trump about the law. By eliminating tax breaks and loopholes, we will ensure that the benefits are focused on the middle class, the working men and women, not the highest income earners. He said that in 2017, right around when the law was passed. And supporters of the law often cite this statistic. The average income tax cut as a result of the law was $1,260 per household. It's a pretty good chunk of change. That estimate comes from the nonpartisan group, the Tax Policy Center. However, some people have a different viewpoint. Here's a quote from Bernie Sanders after the law was passed, several years afterwards. You remember just a few years ago when Trump and my Republican colleagues voted for almost $2 trillion in tax breaks for the wealthiest people in this country and the largest corporations. Very different take on the law. And critics say that the wealthy saw large tax breaks, whereas low income and middle income families didn't get much tax breaks at all. So today's key analysis will be, did Trump's tax cut help, quote unquote, the average American? We're going to analyze that question statistically. If you'd like to follow along using our guided notes, please print them up at this URL. The first topic we're going to talk about is the 5-number summary. So we're going to go back to a simple data set that we looked at in a previous lesson. These are salaries at a company of 12 employees. Here's each of their salaries. These are given in thousands of dollars. And we found in a previous lesson that the first quartile among these salaries was $34,000. The median was $34,500. And the third quartile was $41,000. Let's add on to that two new statistics, the minimum and the maximum. The minimum salary of the company is $29,000. The maximum is a whopping $185,000. The boss is making a fair amount of money. And this right here is what we call in statistics the 5-number summary. The minimum, first quartile, median, third quartile, and the maximum. So now let's talk about determining outliers. So in a previous lesson, we graphed a histogram of the salaries of this company, and we were looking at, are there any outliers here? Outliers are unusually high or low data values, and we can already kind of see a couple. Maybe that boss's salary might be a high outlier, but this is kind of a wishy-washy way of doing it, just seeing it visually. We need to have some sort of way to determine if something is an outlier or not. And that's where these two formulas come in. This is the formula for the upper and lower limits of data, which we consider non-outliers. The upper limit is Q3 plus 1.5 times the IQR. The lower limit is Q1, quartile 1, minus 1.5 times the IQR. Any data values above the upper limit are considered outliers. Any data values below the lower limit are considered low outliers. So in our data set, remember, we already calculated the quartiles, and we found that quartile 3 is 41,000, quartile 1 was 34,000. Subtract those, you get an IQR, an interquartile range of $7,000, Q3 minus Q1. So we can go ahead and plug these values into these formulas. We had Q3 of 41,000 plus 1.5 times the IQR, the interquartile range of 7,000. And for the lower limit, we had 34,000 minus 1.5 times that same IQR. We get the following upper and lower limits. So what this means is that any data values above $51,500 are going to be outliers. Any data values below $23,500 are going to be also outliers. Above the upper limit is a high outlier. Below the lower limit is a low outlier. So here are our limits plotted on the data values, and we can see that there's no data points below the lower limit. However, there are two high outliers above the upper limit, the salaries of $67,000 a year and $185,000 a year. So those two would be considered outliers. Now let's look at box plots. So here is a box plot. We have on the box plot Q1, median, Q3 represented in that box. The box starts at Q1, ends at Q3. The median is aligned within the first box. And then we have the minimum and maximum, which is how far left it goes and how far right it goes. Note here that with box plots, sometimes you'll see dots. These dots are outliers. Whenever you have an outlier, you have to graph it as a dot. And then the whisker on the box, that line, will end at the last data point that is not an outlier. Note that also visually, this is a good way to visualize the IQR because it's just the length of the box, the difference between Q3 and Q1. So it's a nice way to visualize our 5-number summary, visualize outliers, and it's fairly simple. Now, with box plots, there's different features that you can point out. For example, if you see a box plot that looks like the one at the top here, that might be right skew, where you see the vast majority of data towards the left with some outliers and maybe some skewness on the right. You can see the same kind of idea with left skew below. So let's try and make a box plot for our small data set of salaries. Here's again the 5-number summary for our salaries data set. And again, we had 2 high outlier salaries on the right. So let's take this information and construct a box plot out of it. Here is a box plot that we would make. This is not to scale. No, we have to make our box plots to scale. We'll show that in a second, but this is just to demonstrate the different features of the box plot for now. Note that our whisker starts at the minimum point, 29,000, and the box starts at Q1. We have a line in the box for the median. The box ends at Q3, and then we stop at that salary of 43,000 because that was our highest salary. That's not an outlier. We have 2 dots for the high outliers. Now let's analyze this. What percent of the data is below quartile 1? Well, generally, in this data set, there are 3 out of 12 data points below Q1. That's 25% of the data. And generally, 25% of the data is going to be below Q1. What percent of the data is below Q3? In this case, we have 9 out of 12 salaries that are below Q3. That's 75% of our data. And in general, 75% of the data is going to be below your 3rd quartile. Think quarters, quartile. 1st quarter, Q1, 25%, 3rd quarter, 75%. What percent of the data is above Q1, the 1st quartile? That's again, 9 out of 12 data points. That's 75% of our data. What percent of the data is above the median? Think of median, that's halfway point. In this case, 6 out of 12 data points, that's 50% of our data is above the median. And what percent of the data is within the IQR, between the 2 IQR points? In this case, that is 6 data points out of 12, 50%. And generally 50% of your data is going to be between your quartiles in that box, in the box plot. Now here's our box plot drawn to scale. You see we got a scale at the bottom with a label of salaries, and we have tick marks showing the exact scale. And you can see here it looks very different. We can see, whoa, those are definitely some high outlier salaries. That boss is getting paid a lot more than some of the employees. Note, we always have the saying, title, tick, tick, label, label, label. We have a title here, salaries of the company. We have tick marks showing our scale, and we have labeled the axis at salaries of dollars. Now let's describe this distribution. We're going to use, again, CSOCs, context, shape, outlier, center, and spread. And for a box plot, this is what we want to do. Context stays the same as we've seen before. It's the subject of the data, the variable that we're measuring. But shape, outlier, and spread, for shape, you just want to talk about skew. You cannot talk about modes because we don't see any humps because the box plot doesn't have that feature. For outliers, we have the dots, so you want to name each dot as an outlier. For center, you want to discuss the median because the median is shown explicitly on a box plot. And for spread, you want to discuss the IQR because that is also shown explicitly on a box plot. And we saw in a previous lesson, the IQR is resistant to outliers and skew, unlike range. So we can say for this one, if we're putting this together and to describe the distribution answer, data was collected on salaries at a company. That's context. The distribution appears to be right skewed. We can see those high outliers on the right. That's definitely a right skew. There are 2 high outliers at $67,000 and $185,000. I've named my outliers in context. The median of the distribution is $34,500. That's my center. The IQR is about $7,000. That's my spread. And that brings us to our final topic, comparing distributions. For this topic, we're going to go back to our key analysis for today about this tax law. Remember, supporters of the law cite this statistic. The average income tax cut as a result of the 2017 tax reform was $1,260 per household. Now, let's think about this for a second. What kinds of tax plans could lead to an average tax cut of $1,260? So let me put out these theoretical distributions for you. Let's start with tax plan A. This is a distribution of tax cuts per household in America. And this distribution of tax cuts, ranging from 0 to a little bit over $2,000, would result in an average tax cut of $1,260. Let me also show you another potential tax plan. This is tax plan B and a distribution of tax cuts that could happen in another type of tax plan. And we could see here a very different shape compared to tax plan A, a lot of high outliers, with the vast majority of the data being below about $500 and certainly below $1,000. in tax cuts. But here's the thing, tax plan B would also lead to an average tax cut of $1,260. So let's compare these distributions. And we're going to use CSOX for this, as well as comparative language. Whenever you compare distributions, you want to say something is less than, greater than, similar to, when you're comparing the different features. That will get you points on your FRQs. You want to make sure you do this for any time you're comparing dot plots, stem plots, histograms, or box plots. So let's go ahead and compare. We want to use our CSOX. The context here, again, is tax cuts under two different theoretical plans. And the shapes, let's first discuss that. So A looks like it has a slight left skew. If I were to draw the data in terms of like a dot plot or a histogram, you might see a slight left skew. We see that the box plot's a little bit longer on the left side and has a little tail. Whereas tax plan B has a pretty severe right skew. We see a bunch of high outliers, with the vast majority of the data being low tax cut values. Now let's look at outliers. So A has no outliers. B, you see all those dots, has a ton of high outliers. Centers, we have box plots. We're going to discuss the medians. We see that B has a lower median of about $200 and A has a higher median, about $1,400. And the IQRs also differ. We see that there is a bit more spread in tax plan A with a higher IQR of $1,500. The range is higher in tax plan B, but the IQR is only $400. So when we put this all together, we would say household tax cuts under plan A are slightly left skew, whereas they are severely right skew under plan B. There are no outliers under plan A, while there are many high outliers, higher than $1,250 in plan B. The median tax cut under plan A is higher than that of plan B, $1,400 to $200 respectively. And then plan A also has a higher IQR, about $1,500, compared to plan B, about $400. Now, recall, both tax plans have an average tax cut of $1,260. Which tax plan shows a type of set of tax cuts that benefits a broad swath of the American population, and which shows a tax cut that mostly benefits only a small minority of households? A shows a broad tax cut. We see that 75% of households had tax cuts of $500 or more. We can see that Q1 is first quartile is at 500, so that's where we get the 75% of households having higher than that tax cut amount. Plan B shows a more narrow tax cuts. Only 25% of households had tax cuts of $500 or more. We see that its third quartile is at $500. So that means that only 25% of households are enjoying tax cuts higher than $500. And the reason that these two tax distributions have the same mean, we can see that plan B has a lot of high outliers. That is probably dragging up the mean. Remember, mean is not resistant to outliers. We learned about that in our last lesson. So let's go ahead and discuss what this means. Here is the actual distribution of tax cuts for different income levels according to the Tax Policy Center as a result of the 2017 tax law. We looked at theoretical distributions for, here's what this actually looks like. And this is the summary data that we have access to. So let's discuss this. And I want you to take a look at the real data and think about these different statements. First, statement A, only the wealthy benefited from the 2017 tax reform. The middle class didn't benefit at all. Look at the actual data and tell me why this statement might be misleading. Question B, or statement B, the typical American household paid $1,260 less in taxes because of the 2017 tax reform. Recall, this was the mean tax cut often cited by supporters of the tax law. Is it misleading or not to say this is the typical cut in taxes, and explain why? And then finally, our final discussion question for today, which you're going to bring into class. Sketch a box plot, we're going to call it box plot C, that could represent the actual distribution of tax cuts that is consistent with the data we just showed earlier. Compare the medians and maximums of the distributions between theoretical distribution A, theoretical distribution B, and C, your distribution based on the actual data that you just saw in the previous slides. In your view, is C a fair tax cut? And explain your reasoning. That's all for today's statisticians. We'll see you next time on Scoop Script.